When your stick hits the pad on a V71, a lot happens. You can be triggering up to 3 instruments. You can be processing the sound on each of those instruments independently. You can be processing the sound on that pad, so all of those instruments combined. There is some processing that can be shared among pads. You can be processing at the entire kit level, and there's a whole lot of effects you can be adding. So I think to really understand this, we're going to take a step back today and look at the signal flow through the V71. This is going to be a little more technical, but I think it's going to be worth it. Let's go. We're going to look at the entire signal path from 2 perspectives. First, we'll use some simplified diagrams to understand the overall flow. Then we'll look at the corresponding screens on both the V71 sound module and the V71 editor. Most of your editing likely happens on the sound module while you're sitting at the kit, but the V71 editor can be really useful for seeing more of the signal path on a single screen and exploring existing kit designs. In future episodes, we'll dig more deeply into how to adjust many of these individual processors and customize sounds. For now, to keep this video from becoming hours long, this episode will concentrate on understanding the signal flow and explaining some of the options that are easy to misunderstand. Let's look at another simplified overview of the signal flow and build it up. I want to emphasize the word simplified. Roland does not publish every internal DSP connection or the exact order of every processor. These diagrams are meant to provide a useful functional model, not a reversed engineer schematic of the V71 software. By the way, if you want the closest thing I have found to a source of truth, use the data list manual and scroll to the bottom and look at that block diagram. On the left side of our simplified diagram are the instrument layers. A pad can contain as many as 3 instruments, labeled here as instrument A, B, and C. For this diagram, an instrument layer includes the selected instrument and its V-edit settings. Each instrument layer has its own processing. The editor presents the layer controls from left to right as V-edit, transient, EQ, and layer settings. For our functional map, we'll follow that same order. The 3 layers are then combined into one pad signal, and then you can modify just that pad's tonal character. After that, you get various processors that work on combination of the pad and the entire kit. In this version of the diagram, I'm showing the ambience, bus effects, and optional bus reverb processing blocks. These are not simply a series of processors where the sound must pass through ambience and then bus effects. They are largely parallel paths whose results are combined later. And remember from the previous diagram, there is a dry path that can bypass all of this. The completed pad signals, the ambience returns, and the bus effects returns are then combined into the overall kit mix. The kit can then pass through some final processing and go to the output stages. I've left off a lot of detail, but we are going to dig down a little more. If you ever feel lost, feel free to come back to this diagram to get grounded. We need to start with the instrument signal flow. We already looked at the instrument, V-edit, and layer tabs of instrument processing in a prior video, and my feeling is these are some of the most common and useful editing features, so make sure you watch that video. You don't need to understand anything from this video to make good use of those features. I did not cover the transient and EQ tabs, and for now I just want you to know where to find them and to emphasize that this EQ is on the layer level. You will see multiple other EQ settings, but this is the last time you get one that operates only on the instrument layer. This seems a little more obvious on the V71 editor, where the instrument layer is shown with the V-edit parameters on the left, followed by the transient properties, followed by EQ, and the layer settings on the rightmost side. Each layer gets its own row on this screen. Moving to the right, our flow diagram brings us to the pad processing block. I've added the EQ and compressor blocks in this version. On the V71, this is found under the EQ compression button. The pad EQ section lets you shape the combined sound of the selected pad. On pads with separate zones, such as a snare, you can have separate head and rim EQ settings. When head and rim link is active, changing one set of controls changes the corresponding controls for the other zone. Next to the pad EQ is the pad compressor. Again, this compressor acts on the combined pad signal, not on the individual instrument layers. Therefore, if the snare uses 3 instrument layers, all 3 are combined before reaching this compressor. At the instrument level, each layer has transient processing and EQ, but no conventional layer compressor. The first dedicated compressor in the basic signal path is at the pad level. In the V71 Editor, pad EQ and pad compressor appear under the combined mixer pad EQ/comp area. The workflow from here is to select a pad from the mixer or the kit graphic. If H&R link is off, select the head or rim zone you want to edit, then adjust the pad, EQ, and compressor. There are other controls here for ambience and bus effects routing that we will ignore for now and revisit when we get to those portions of the diagram. The V71 provides 4 separate ambience components: overhead, room, reverb, and kit resonance. When you press the ambience button on the V71, you see this screen. You can see tabs across the bottom for those 4 areas. What happens on this screen confused me quite a bit at first. The sends on the left control how much signal from the selected trigger, and in this case that's the kick, goes into the ambience processors. The section on the right is shared by the entire kit. It allows you from any single trigger to turn on or off any of the 4 processors for every trigger, and to set the return level of any single processor, as well as set the overall level of all 4 processors. Again, changing the level changes it for every trigger in the kit, not just the currently selected trigger. So to repeat, the left side answers how much of the currently selected pad should be sent into each ambience processor, and the right side answers how is that shared ambience processor configured and how loud is its result for the entire kit. That distinction, pad-specific sends feeding kit-wide processors, is the key to understanding every ambience screen. This unassuming overhead box in the ambience area is a little more complicated than it might seem. It deserves its own signal flow, and that looks like this. Before we look at the V71 controls, let's understand what's happening here. For the selected pad, there are 2 main controls: overhead send level and filter assign. The send level is what we just saw on the previous V71 screen, how much signal we want going to this processor. The filter assign box needs a little extra explanation. You can either bypass filter or choose one of 6 shared filter configurations. Each of those 6 configurations contains both a pre-filter and a post-filter. So, for example, the kick might use filter 1, the snare might use filter 2, and the toms might all use filter 3. Each pad can therefore enter the shared overhead system with its own pre- and post-filter settings. The pre-filter shapes the signal before it reaches the rest of the overhead processing. Next is the pre-transient section, which can alter the attack and release characteristics of the signal before it reaches the virtual microphone system. After that is the pre-compressor, which controls the dynamics of the signal entering the microphone stage. Then we reach the main overhead microphone controls: mic type, distance, time, width. These settings define the overall character of the virtual overhead microphones and are shared by the entire kit. Again, that distinction is important. Changing which filter configuration the kick is assigned to affects only the kick. Editing the settings inside that filter configuration affects every pad assigned to it. After the microphone stage, the signal moves through the post filter. The signal then passes through the post EQ and post compressor. Finally, overhead level controls how loudly the completed overhead return is added to the ambience mix. Overhead send level and filter assign are pad specific. The microphone settings, shared processing, and overhead level affect the entire kit. When you select the overhead tab from the ambience screen, you'll see a screen like this. Note that there are tabs across the top and tabs on the bottom, so there is quite a lot to access starting here. One thing I want to point out is the overhead only slider. When you turn that on, it turns off the dry signal temporarily. It lets you hear just what the overhead processor is doing. It's very valuable. If you leave this on but exit the overhead screen, it smartly turns itself off. The other ambience processors have similar only sliders that work similarly, so I won't mention them every time. Instead of navigating through all of these screens, I'll let you do that on your own, and instead I'm going to use the V71 Editor screen to explore them all. There are 2 ways to toggle the overhead processor on and off. And you also have access to the overhead only feature here as well. The template dropdown we saw on the V71 overhead screen is here, and it automatically sets all the other areas for you. So you can adjust it to get close to what you want and then tweak specific settings. On the module, these controls are spread across 5 upper processing tabs and the lower send, filter, assign, and overhead tabs. The editor places nearly all of them on one screen. The only missing upper tab is Bus Send, which appears in the Bus FX routing view. To summarize, overhead send level and filter assign are pad specific. The microphone settings, shared processing, and overhead level affect the entire kit. That is the main idea to keep in mind when working with the overhead section. We are ready to move on to our next box, the room processor. Much like the overheads, there's a lot contained in this one box. The room processing chain is almost identical to the overhead, with the exception that there's only one pre and post filter, and it's labeled pre-EQ and post-EQ. And instead of configuring the overhead mics, you configure the room. The screen on the V71 looks similar too, with recognizable tabs across the top and only a send and room tab on the bottom. Again, I'll use the V71 Editor. The basic idea is similar to the overhead section. Each pad has its own send level, shown here at the bottom of the screen, but the room processor itself, at the top of the screen, is shared by the whole kit. So with the snare selected, the room level determines how much snare signal is sent into the room processor. If I switch to the kick, toms, or cymbals, each of these pads can have its own room send level. That is the pad-specific part of the signal flow. Once the signal enters the room processor, the first shared stage is the pre-EQ. This shapes the signal before it enters the room simulation. Next is the pre-transient section. This lets you alter the attack and gain characteristics of the sound before the virtual room responds to it. After that is the pre-compressor, which controls the dynamics of the signal entering the room processor. Then we reach the room processor itself. This is where we choose the type of room and adjust parameters such as room type, place, character, and several other parameters. We'll save diving deep into those for a dedicated room tutorial. After the room simulation, the signal passes through the post-EQ. After the post-EQ is the post-compressor. This controls the dynamics of the completed room sound. Finally, room level controls how loudly the shared room return is added to the ambience mix. Next up in our ambience flow is Reverb. Reverb follows the same pad send to shared processor model, but its processing chain is simpler, and it's similar to what we've already seen, so we're going to go a little faster here. The pad-specific portion is the reverb send level at the bottom. Everything after that is part of the shared reverb processor. The first stage is pre-transient. This lets us change the attack and gain characteristics of the signal before it enters the reverb processor. After that, the signal enters the main reverb processor. This is where we choose the reverb type and adjust the parameters that define its character. The parameters here vary based on the type selected. After the reverb processor, the signal passes through the post-compressor. A more aggressive setting can make the reverb tail feel denser and more consistent. A lighter setting can leave more of the natural variation between softer and harder hits. Finally, reverb level controls how loudly the completed shared reverb return is added to the ambience mix. We've reached our final ambience processor, kit resonance. Kit resonance is intended to add some of the interaction you would hear from an acoustic drum kit, where striking one drum can excite the shells, heads, and air around the rest of the kit. Like the other ambience processors, kit resonance combines a pad-specific control with a shared processor used by the entire kit. The stages of processing are likely starting to feel pretty familiar. Let's jump into the editor. Again, we can control how much signal goes from each pad into the processor. The first shared stage is the pre-EQ, followed by pre-transient. As with the reverb and room sections, processing before the effect can influence how the effect responds. After that, the signal enters the main kit resonance processor. Drums type selects the basic resonance model with standard set and small set available. Time controls duration, and character changes the tonal quality. We'll compare those models in a separate video. After the resonance is generated, it passes through the post-EQ. Finally, I have a post-compressor. Finally, resonance level determines how loudly the completed shared resonance sound is added to the ambience mix. That completes the 4 main ambience processors. In every case, individual pads feed shared processors through pad-specific sends and through the ambience section of our diagram. Now we're going to move into bus effects, where the routing becomes more flexible and a little more confusing. This can be fairly complicated, so I need to use diagrams to explain all the options, and once we get through that, we can look at the editor and see how you control all these options. I think it's worthwhile to talk first about how the signal gets into the bus effects section. Our simplified flow diagram has served us well up to now, but it's a little more complicated than this, so here we go. Your first decision in this section is to decide between working at the head rim level or at the pad level. When you work with the head rim separately, a couple of things change. First, the signal is tapped off before the pad compressor. Second, you get separate send levels for the head and the rim. And then if you unlink the head and rim, you can send them to separate buses. You can later turn back on linking, and as long as you don't make routing changes, the head and rim continue to go to separate buses. In the pad mode, the signal does go through the pad compressor like our diagram has shown. You get a single send level, and then it can be sent to one of the 4 buses. The H&R link button doesn't affect anything in this mode. One other wrinkle has to do with the sends versus inserts, and we're going to talk about that in a moment. When we do, I will point out that I call them send level controls. When you insert the signal, there are no level controls. This will make sense when we talk about what an insert is. So that's it for pad versus head and rim. Moving forward, we're just going to discuss the signal that comes into the bus effects area. Whether our signal comes from the pad or head and rim, we can now think of it the same way. The signal comes in and we can do one of 3 things with it. We can just send it on and pretend the bus effects section doesn't exist. We can send it on and send it into the bus effects section. It can go to one of 4 buses labeled A through D, and each one of those buses can have 2 effects areas. The signal first goes to FX1 and then to FX2. Each effects can be configured separately to be either a simple through, that is, there's no effect, or it can go to any one of dozens of effects, or even a pre-combined pair of effects. This means we can use each bus for 0 through 4 effects. In addition, each bus can optionally be routed with the effects applied to a single bus reverb area. Our third option is to insert the signal. The term insert comes from the world of traditional mixing consoles. An insert breaks the normal dry path and places the bus effects directly into it. The sound must pass through the bus before continuing to the kit mix. Now we have a signal coming in from either the pads or the head and rims, and it is either being sent or inserted. We can direct that signal to one of the 4 buses labeled A through D. Each of those buses will take the incoming signal and pass it through the 2 effects sections. Then it can optionally be sent to a bus reverb section that will apply reverb and a bunch of other settings to the process signal. You can control how much signal comes in from each of the 4 buses. There are many parameters you can control in this reverb section, and we'll only look at it briefly. So in the head and rim, we can have a total of 8 effects applied to a single pad, and we can apply optional reverb. Surely that's enough. Well, it turns out you can also chain from one bus to another. And of course, you can do it as a send or an insert. After bus A, you can send the signal on its way to the output and control how much of it goes to another bus. Once in that other bus, you can do another send, or you can insert the signal down to another bus. When you do that, the normal output is removed. This is a one-way street. A can go downstream to any of B, C, or D. B can only go to C and D, and C can only go to D. D can only go to the normal output. You cannot send, say, bus C back up to bus A. So that's got to be it, right? Well, there is one more bit of flexibility in the effects section. The bus effects supports the concept of a sidechain. A sidechain is a separate control signal. One pad can control a compatible effect that is processing another pad. Page 59 of the data list manual uses a footnote of an *1 to signify which effects are sidechain compatible. In this example, the snare audio is being processed in bus B. A separate control signal from the kick is sent to FX2 in bus B. If FX2 is a compatible effect like a gate in duck mode, each kick hit can temporarily reduce the affected snare signal. And it's important to remember that only specific effects support sidechain inputs. The sidechain can control either FX1 or FX2 or any of the 4 buses. The kick does not need to be audibly routed through bus A or through any bus to provide this control signal. Its normal audio routing and its sidechain control send are independent. You also get control of the send level and a pre-gate on the sidechain send. Out of curiosity, I scrolled through the 150 or so kits I have loaded, and not one of them uses the sidechain feature. Okay, that's it. Let's go over to the editor's bus effects routing tab, which has control for all of these features plus a few more. Before we get to bus effects, let me quickly cover the routing for the ambience effects we talked about previously. That's the section here to the left. We can do 4 things here. 1, we can control the level going into each ambience processor. 2, we can turn each processor on and off. 3, we can adjust the level coming out of each processor. And 4, we can send each processor to one of the 4 effects buses. Okay, now back to the features we just discussed. First, let's select pad. Now, using the label next to head, we can route via send or insert to any of the 4 buses by dragging or with the mouse wheel. Each time we are on a send, we can control the send level, and you can see the signal going out to the right. When we select an insert option, the level control goes away, as does the line leading off to the right. If we switch to head and rim, as long as we are on a compatible source like a snare, we will get an extra set of lines with head selected. Those lines are shown in yellow. If we switch to rim, those lines highlight. If H&R link is on, changing the routing changes both sets of lines. If I unlink, I get separate control of the send levels and the destination. If I link back and change the send level, the 2 send levels sync up, but the destinations remain different. If I change the destination, then both destinations sync up. I'm going to simplify the screen and go back to pad for the remainder of the demo. Either or both effects can be turned off. You can select effects from the name. When you select a side chain compatible effect, a box labeled SC appears, and when the effect is on, you can turn on the SC input. Later, we'll see how to route the signal to the effect to make it do something. Then there is a return level control. Moving to the right is the bus A label with the line leading to the output bus. We can use this label to control chaining. You can see the send adds an additional send level control and routes the signal to another bus. The insert takes away the return level control and routes the signal to another bus. Each bus works the same way, but it is limited to the allowed downstream destinations. The editor doesn't show any lines leading to the reverb section, but you can mentally draw them in. The 4 input level controls attenuate the amount of signal the reverb section receives. The reverb level controls the overall return for all 4 buses. If you turn off both effects in a bus, then there is no output level for the bus. If you want the reverb but not the effect, use the through effect and leave the effects turned on. Only one of the 2 effects needs to be on for the signal to propagate. You can turn off the bus reverb both here and in the bus reverb box, but all the reverb parameters can be accessed over here in the bus REV tab. Similar to our ambient section, there are pre-transient, reverb, and post-compression settings. The parameters vary based on the reverb type chosen. That only leaves sidechain, and the control for that is here in the lower left. When you make a selection, a new line comes from our direct signal down to whichever bus we select. When the sidechain is enabled for a compatible effect, we can control the level, and we have access to the pre-gate. All the options for the gate are on the right under the Gate tab. One last thing before we go. When you are exploring kits, you are seeing the bus effects for whatever trigger source you have selected. The Assign tab can both be used for assigning bus effects and sidechains, but also provide a way to see every instrument that uses an effect as you cycle through kits. Well, I hope this diagram now feels less like a wall of boxes and more like a map you can use to get you to your final sound. When you open a V71 screen, you should have a better sense of whether you're editing an instrument layer, a pad, a shared processor, or the complete kit. Let me know if using the V71 editor was helpful or if you only want to see the module screens in the future. If there was an ambience topic or other area you want a deeper dive on, let me know that too. Thanks for watching and rock in peace.